talking more about the basics of significance testing. Quick recap of the last video, talking about stating our hypotheses. So remember, the claim that's tested by a statistical test is called our null hypothesis. The test is designed to assess the strength of the evidence against the null hypothesis. Often the null hypothesis is a statement of no difference, or that the claim is true. The claim about the population that we are trying to find evidence for is the alternative hypothesis. Remember, we talked about H sub 0 and H sub A. So an example, we could have a proportion that is equal to 80%, or 0.8 for our null, whereas our alternative could be the proportion is less than 0.8, where P represents the proportion of the long run proportion of made free throws. Say it was a basketball example. Like we said, the null is always going to be an equal to, the parameter is equal to some value. The alternative has one of three different forms. Either it's less than, greater than, or not equal to. To determine the correct form of your alternative hypothesis, you have to read the problem very carefully. The alternative is one-sided if it's larger than the null, or if the parameter is smaller than the null. It's two-sided if it states that the parameter is different from, so it could be larger or smaller. Now remember, hypotheses always refer to a population, not a sample. Be sure to state that your null and your alternative in terms of the population and the parameters. In this chapter, we'll be dealing specifically with P and mu, but it really could be sigma, it could be anything like that. It is never, ever, 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 ever correct to write a hypothesis about a sample statistic. You should not use p hat or x bar or s in your hypotheses. Now let's talk about a p-value. Assuming that the null hypothesis is true, what is the probability of getting a statistic at least as extreme as the one observed in a study? That is our p-value. So how do we interpret such a thing? Well, the null hypothesis states that the claim that we are seeking evidence about. So the probability that measures the strength of the evidence against the null hypothesis is called a p-value. The probability is computed assuming that the null hypothesis is true, that the statistic would take a value as extreme as or more extreme than the one actually observed is our p-value. So the smaller the p-value, the stronger the evidence against the H sub 0 provided by the data. If the null hypothesis, so this little part here in italics is going to be your way to interpret a p-value. So if the null hypothesis of, insert your context here, is in fact true, there is a, insert the p-value, chance that we obtained a result as extreme as, insert sample value due to random chance alone. So here's an example. Say your null is 0.9, your alternative is that your proportion is less than 0.9, your sample p-hat was 85%, and your p-value is 0.035. where P is the seniors attending college at a certain school. So, if the null hypothesis of 90% of these seniors attending college is indeed true, there is a 3.5% chance that we obtained a result as extreme as 85% college attendance due to random chance alone. Okay? So if we were to do a simulation or something, the chance that we would get those results is that by chance alone. So, if you have a small p-value, there is going to be evidence against your null, right? It means it's unlikely to occur if your null is true, so we say we reject that hypothesis. Now, if you have a larger p-value, it means there's not convincing evidence. It could occur if the null were true, so we're going to fail to reject it. So let's talk a little bit more about p-value. Think back to conditional probability, right? What's the chance that this thing happens given that this thing is true? So in our CEO example, the p-value was 0.008, right? What's the chance that we would get a sample statistic of 0.12 if the true proportion is in fact 2/12 or 1/6? So how would we interpret that? Well, power's about to die. Assuming that the birthdays of corporate CEOs are uniformly distributed throughout the year, there is a 0.008 probability of getting a sample proportion as small or smaller than 0.12 by chance alone. Let's do the one with Mike. For the 7-iron, If we have a sample standard deviation of 13.9, the p-value is 0.28. So if, in fact, the true standard deviation is 15, then there's a probability of 0.28 that the sample standard deviation would be 13.9 yards or smaller by chance alone. So p-value is the chance that this would happen, or smaller if we're assuming that our null is true.